people who's like monitoring, it's like operators, they will give them like just this feeling that they are inside of the pipe. If you watch the movie Real Steel, so where the kid is like dancing and the robot is repeating, this is the same technology. It can be done by kids as well. We had some very tough times, like when we saved like every pence, isn't it, every coin of it. So just survive and just complete my PhD degree. If the researcher has no sense of humor, that will be very hard to survive in this field.
Water, gas and oil flow continuously through pipelines. These pipelines run deep underground, connecting districts, cities and entire systems. We don't see them, but they are what provide us with heat, electricity and water. If a pipeline breaks, life can come to a halt. A city may freeze. A fire may ignite. Oil can leak and contaminate the soil and water. A pipeline accident is a serious threat to both people and the environment. Over time, pipelines age and wear out. Cracks and rust begin to form. Sometimes pipelines are damaged on purpose. If the problem isn't identified in time, it can lead to a catastrophe. Kazakhstani scientist Azamat Yeshmukhametov has proposed a new way to ensure uninterrupted and safe pipeline operation. Together with his team, he created a robot that can enter the pipe, detect damage and repair it from the inside without excavation and shutting down the system.
This technology, it calls like this master and slave. Master and slave, if you watch the movie Real Steel, so where the kid is like dancing and the robot is repeating, this is the same technology. This is the same technology, and by allowing this one, like we can just like put here any tool, multi-tool, isn't it? So by this kind of like a multi-tooling, so we can conduct any kind of like a repayment work, what is exactly necessary. So we are just conducting like just grippers to remove all of the stuff. Sometimes like in the building of this kind of like a pipeline, some workers can forget their tools inside of it. So we can remove that one as well. So we can detect first, and also one of the novelty here is like anomaly detection. Anomaly detection, that means like you have a pipe and there should be nothing inside of it. So this robot can detect any anomaly. So this could be even the animals inside of it, like or sand, which is like entering somewhere else, isn't it? Or tools, which shouldn't be there.
Dr. Azamat is working on constructing the robot, which will have a camera, which will have a implementation of AI, artificial intelligence. It will be like machine learning plus computer vision. So basically, the robot will enter inside the pipe and will inspect the internal part, like whether there are any cracks, rust, corrosion and so on, and provide some analytical report, which part has a deformation, on which part of the pipe we need to pay a lot of focus. If, for example, we are talking about the oil and gas sector, sometimes like the pipes are under the knees, so it's sometimes difficult to get inside for the people and inspect. And with this small and mobile robot, it's much easier to inspect and it will give some more efficiency. Plus, sometimes there are some not reliable suppliers who can supply some second-hand or used pipe. So in order to make sure that this pipe is in line in accordance with all the technical specification, this robot can be used to justify this. As I told before, just by giving an example, it can be for sure oil and gas sector, then energy sector, then the city pipeline infrastructure.
The prototype developed by Azamat Yeshmukhametov's team is designed for pipes with a diameter of 40 centimeters, a standard size in industrial use. The technology has already shown impressive results. The robot inspects the quality of weld seams and, if necessary, seals them from the inside. It cleans the inner surface of the pipe, removes debris, performs welding and grinding, and it can operate both horizontally and vertically.
we are creating, and we are testing it in real environment. This is a real pipe actually, so we brought it, isn't it, from the industry used one, and we are here collecting data, and this data collection allows to us to use it to conduct all of the experiments. So vast majority of our research is rely on the empirical data. This is empirical methods we are conducting. This is not like a simulation based, isn't it? This is a real prototypes which will conduct real experiments. So, and we are maximum trying to test it on a real environment. So this allows to us just to be in a pioneering in this field. Right now, this method is pretty easy to implement. For example, one of the main part of my research is I want to simplify the complex things. This is a complex, isn't it? So we simplify it in case of control. For example, this kind of just this manipulation, it can be done by kids as well. For children, also can play it and they can conduct the same operations. And also the same people from the industry, there's no need to spend so many hours or just days to learn it, isn't it? So, and also at the same time, so the neural networks, the machine learning and the AI model, so to detect all of the problems is also very light. So we can use very simple machine and to build to do a very complex stuff.
It takes 3 days to build a single robot. The most time-consuming part of the process is 3D printing. Each component is created layer by layer. Assembly, by contrast, is fast and efficient. With more 3D printers, the entire robot can be completed in just 1 day. For large-scale production, the team plans to switch to mold casting. This will allow them to produce up to 60 robots a week.
So we want to conduct just as a AR technology, VR and AR technology. This is an AR goggle, and the people who is monitoring it's operators. So they will be able to see that one. It's how it's going to be driving, and see. They will give them just this feeling that they are inside of the pipe. So this technology will allow to them just implement this technology. We already started this project. So first of all, we are scanning, 3D scan, and we are converting. This project is very challenging because no one did it before. No one did it before. AR is a new field actually. So no one did it before, so we are trying to get it And another thing is, the technology, what we SLAM, LIDAR. LIDAR is a kind of a lasers, isn't it? Lasers inside of the pipe, it cannot work properly because it's a very too tight space, isn't it? Very constrained space. So LIDAR, it works very good in this room, isn't it? In this room because space is enough. It creates an amazing, great kind of features, isn't it? But inside of the pipe, it cannot do. So that's why we are implementing so many things, and the AI as well. So to build a map with a high resolution. So after this building, so we want to just implement to the operator, isn't it? So they will try to search and study research problem. For example, we have so many here. Here's some cracks and some holes. These holes would be detected the size of the holes, isn't it? So what's the size of the holes and what kind of just parts you must prepare to weld it properly. So this is our future plans. I think very soon, so we will be able to, by the end of this year, so we will be able to complete this project. My father, for him, the idol or someone who is a favorite people, it was researchers only. His jokes and the whole of his stories is behind of the jokes. This might be Kapitsa, Landau, and it's top researchers in the field, isn't it? Einstein. This is all of the jokes and all of the histories, stories about those people, and he was collecting all of this, and he couldn't hide his admiration for those people, isn't it? So, and he gave me kind of a hint of if you become a researcher and a scientist, this is a great thing, isn't it? He want me to just become an electrical engineer. So, because he's an electrical engineer as well. So he said and okay, when I was at 10th grade or 11th grade, like he taught me like just how to connect like some wires and electrical stuff, isn't it? So we did like just some refurbishment work in some houses, and so I was helping to my father is like connect like some motors and just repairing on some that. So that was a great time. That was a great time. It was very basic, and for me that I decided like I just change my direction and to become a robotics. And my father is like his main skill, it was like a job, isn't it? So look at the Azamat, it's like a line grid is everywhere, isn't it? So that means that you can be electrical engineer almost everywhere. So, but there is no robotics in Kazakhstan. So why are you trying just like to study this field? Electrical engineering is a part of robotics, isn't it? So anyway, I will study. And then my father was like, he was very happy to hear that.
Azamat studied robotics at university, and after earning his bachelor's degree, he began working as an engineer. The job seemed stable and interesting at first, but over time he realized that simply carrying out tasks wasn't enough. He wanted to find new solutions, simplify complex processes, and make technology more accessible. At that moment, Japan became the place that offered everything he was looking for: cutting-edge technologies, high-quality engineering education, and opportunities for scientific research. He moved there to continue his work in robotics. That's where he also met his future wife.
She was doing a master course, and I joined it, and we started like we met there, and after when I returned back, so we get married and we built family. And she knows about my research and all of my dream and career. And I'm so glad that like she is very supportive. So she's supporting every my step. And we had some very tough times, like when we save it like every pence, isn't it? Every coin of it. So just survive and just complete my PhD degree. So of course, like she is supporting all of my beginning, and yeah, she's pretty happy, and my kids also happy. They love robotics, and this is a great thing. I love to build something with my kids, kind of like robot parts, and some planes, some aircraft stuff, isn't it? Saturday or Fridays, like this is my task. So I'm just like reserving kind of like just places where my people and my kids and my wife will feeling is it no cooking that days and only just like we'll eat outside only, and also just like a program, is it, for we call like the Sunday program, and work after stressful week. So what I'm doing is stress is fun. So the first thing is like just what I'm doing before the coming to the work is like I go to the sauna. So and especially the first thing is like my lovely thing, isn't it? I love to go to the outsides, like a very cold places, and I just reserve kind of like the sauna, and then I will do kind of like just go to the sauna, and then I love to like just take a shower like outside of it, like when it's like outside is a -20, -15. So this is absolutely perfect, isn't it? I'm trying to freeze myself and then like change the temperature, so to release kind of like some stress, and then after that, like when I'm returning back, I'm very fresh and I'm feeling lots of strength. And recently I bought kind of like a telescope, so I want to go to the outside, absolutely dark places, like just without any light pollution. So and then like enjoy stars. So this is my new hobby right now.
Looking at the stars, Azamat dreams. And his biggest dream is to raise a new generation of engineers in Kazakhstan. He believes that a passion for science begins in childhood. To give children that first push, Azamat wrote 2 books. The first, in Kazakh language, became the country's first textbook on Arduino, an international platform that teaches kids how to assemble and program sensors, lights, and motors. The book helps Kazakhstani schoolchildren grasp the basics of electronics and robotics, and was recently purchased by a school abroad. Azamat's second book is dedicated to the mathematics of robot control. Together with his academic supervisor, he explains complex formulas in simple language so that students won't be afraid of math. The scientist's next goal is to create a school course in robotics, allowing children to explore this fascinating world from an early age.
Every summer we have summer research program at Eastside, which collects students from high school and universities to ARMS laboratory under the supervision of Dr. Azamat, and he's very talented leader to these students who introduced them this great world of innovations and artificial intelligence, and introduced them to this sphere of robotics and how to use them in industry and different manufacturers as well.
Azamat Yeshmukhametov's team won an international research grant under China's One Belt, One Road initiative. The Kazakh scientists are preparing to present their developments in China and to establish new collaborations in the fields of sensor technology and robotics. The team plans to work with researchers from the Hong Kong University of Science and Technology in two areas: sensor development and improving the robot for pipe inspection and repair. For both countries, this is an opportunity to move from laboratory research to real-world implementation. To find partners and build international scientific collaborations, the researcher uses the social network. He posts short videos showcasing his research, shares insights on artificial intelligence and robotics, and tags leading scientists and relevant scientific communities. These posts often attract interest, leading to questions, proposals, and new connections.
But unfortunately, when researchers publish their paper, they never write about negative results and their fails, isn't it? I would be very happy to read someone's fail, isn't it? So someone's fail is will give me more information rather than someone's success, isn't it? So what's mean fail? For example, Thomas Edison to create a bulb, isn't it? So he did it 10,000 times, isn't it? So this is 10 times. This is not a fail, isn't it? This is 10,000 times which doesn't work, isn't it? So he discovered 10,000 ways of the methods how just as bulbs it doesn't work. Only fails will shape the researcher. If the researcher has no sense of humor, that will be very hard to survive in this field.
Dr. Yeshmukhametov has published a scientific paper on a robot designed to inspect and repair pipelines and has patented the technology. The robot has been tested in real-world conditions and is ready to operate inside pipelines. It saves time, reduces costs, and helps prevent gas leaks, oil spills, and bursts in hot water and heating pipes. With simple control system and built-in artificial intelligence, the robot is easy to operate even without specialized training. The scientists' next steps include improving the technology and launching new projects, including ones in the healthcare sector.
We are getting a grant for the 3 years. In fact, the funding is only for 2 years to publish in the top high-quality journals, isn't it? For such a short amount of time is almost impossible. So, for example, my last paper, it was just reviewed for 9 months, isn't it? To improve a Kazakhstan ranking in the world of the science in the world, the Kazakhstan should start to improve extend the period, at least 5 years. In Japan, so there is a terms, the very shortest term is the 5 years. So you're getting a research for the 5 years. And then 7 years and 11 years, 9 years and 11 years.
Azamat Yeshmukhametov is the face of Kazakhstani science. He doesn't wait for technology to come from abroad. He creates it here and now in his own country, in Kazakhstan. His developments help make infrastructure more reliable and bring science and industry closer together. The scientist builds robots that solve real-world problems while also dedicating much of his time to nurturing a new generation of engineers and researchers in Kazakhstan.